ammeter. This is galvanometer G. This represents galvanometer. This is a low resistance in series. Low. The instrument between A and B, this one called ammeter. One a low resistance is connected in parallel with galvanometer. Then their combination called what? Ammeter. Galvanometer, it is a device for measuring low currents. Ammeter, device for measuring higher currents, high currents. This is low resistance in parallel. So galvanometer will be damaged if large current is passed. So maximum current pass through this low resistance. So this low resistance to avoid what? Damage of galvanometer, shunt. This low resistance is shunt. Low resistance connected in parallel with galvanometer called what? Shunt. So what shunt do? It protects galvanometer from damages because the low resistance where high current passes, maximum passes through shunt. Resistance of ammeter let G resistance of galvanometer S low resistance in parallel or what it is, only shunt. Simply S is shunt or it is low resistance in parallel. RA resistance of ammeter then 1 by RA is 1 by G plus 1 by S. 1 by RA it is GS, S plus G. So RA GS G plus S. This is what resistance of ammeter. For example, G 100 ohm, shunt 1 ohm, RA GS G plus S 100 into 1 100 plus 1 0.99 means resistance of ammeter is very low, even lower than shunt. Shunt resistance was 1 ohm. Resistance of ammeter comes up to be 0.99, even lower than shunt. For ideal ammeter, resistance is 0. This is ideal ammeter. So this is what ammeter. Ammeter, it is device for measuring large currents. Current through ammeter current through galvanometer in ammeter. This is the question. Expression for current through galvanometer in ammeter. This is a galvanometer. This is shunt. Between A, B, this is what? Ammeter. See, this is battery. This is current through circuit. What is expression for current through galvanometer? This is the question. Current through this galvanometer, say Ig is current through galvanometer in ammeter. ये दिस वाज एमीटर, इस एमीटर में ये जो galvanometer में है इसमें कितना करंट जाएगा? This is our question. Current through galvanometer in ammeter. Let I be potential difference across ammeter. I current through circuit. Ig current through galvanometer. Then this current will be what? I minus Ig. Now we Ri, Ohm's law. Ohm's law across galvanometer, Ri. Same V across shunt. Same potential difference is across shunt, so Ohm's law, Ri. Same potential difference across galvanometer, so Ri. R here is G, I is Ig. Gig, Si, Sig. Take us to this side. Gig, Sig, Si. Ig common. G plus S, Si or Ig, Si, G plus S. This is what expression for current through galvanometer in ammeter. Special case IS, current through shunt. Current through shunt. IGS, Ig it was S. Here it was G plus S into what? I. Similarly, Ig was S plus S by G plus S. So Is, current through shunt, instead of S, there should be G plus S into I. So this is current through galvanometer in ammeter. Voltmeter. This is what galvanometer. This is what high resistance. This instrument is what voltmeter. What I said, This is galvanometer, this is high resistance. What is their combination? It is voltmeter. It is device for measuring potential difference. When a high resistance is connected in series with galvanometer, then their combination called voltmeter. Resistance of voltmeter G, resistance of galvanometer R, high resistance RV, resistance of voltmeter, then RV G plus R, that is very, very high. For ideal voltmeter, resistance infinite, say this is 100, this is 1000, very large. Resistance of voltmeter is very, very large. Question: in electric circuit, ammeter always connected in series and voltmeter in parallel. Why? This is electric circuit. This is ammeter. This is certain resistance. And this is voltmeter. The ammeter is in series. The ammeter it is in series, voltmeter in parallel. Ammeter is having very low resistance, so connected in series so that current easily pass through measured. ये सीरीज में लगा दिया, करंट easily pass through it. But voltmeter is having a very high resistance. So cannot be connected in series because it will not allow current to pass. So connected in parallel to measure potential difference. A current passes here. This is current, and this voltmeter, it measures potential difference. Where? Between 2 points. This is a circuit. This is a resistance. This is a galvanometer. This is shunt, keys, battery. Current flowing through galvanometer Z when key 2 is left open is I. This key is not inserted. Then current through this galvanometer is I. This is the question. If this is inserted, current through galvanometer is I by N. Again, not inserted, current through galvanometer is I. Then this key K2 is inserted, current through galvanometer is I by N. We have to find a resistance Rg of galvanometer in terms of S, R and small n. This is our question. This is circuit. Again, question. Not inserted, current is I. Inserted, current is I by N. Find resistance Rg of this galvanometer in terms of S, R and small n. When K2 not inserted, resistance R plus Rg. Rg is resistance of galvanometer. This is Rg, resistance of galvanometer. R plus Rg, they are in series. Then E is Ri. This is R and this is what? I. K2 inserted. Resistance R plus Rp. Now this is the resistance R plus Rp. And what is this Rp? Rg S SRG S plus Rg, or Rp is SRG S plus Rg, or Rp SRG S plus Rg. It is Rs. S plus Rg is LCM. Rg Srg by S plus Rg. This is now resistance. Then E Ri this is R. I. Now as the resistance is different, so current will be different. This was current I. Here was I when Q2 is not inserted. Now the current is I dash. Here it is I dash. We know Ig S G plus S into I, current through galvanometer. This is the total current. Formula: current through galvanometer S G plus S into I. Now current in circuit is, instead of I, it is I dash. This is I by N. S is S, G is Rg, S is S, I dash. So E, Rs, Rrg, Srg, S plus Rg into I dash. This was I by N. I dash. It is I by N Rg plus S by S. They are cancelled. It is what? E Rs, Rrg, Srg, I, and it is N, it is S. From first and second. R plus Rg into I, Rs, Rrg, Srg, ns into I. This I goes with this I. Solve it further. Multiply this ns here. ns r ns rg rs rrg SRG. We have to calculate RG. Take this to this side. R plus S minus NS. Take this to this side. NSR. Take this to this side. SR. RG, SR common, N minus 1. This is RS 1 minus N. This is what resistance of galvanometer. When R very large than S, this S neglected, RG becomes SR n minus 1. This is 0, not 0, ये इफेक्ट करेगा रिजल्ट को. This is 0. So it is R. So RG becomes S n minus 1. So this is what resistance of galvanometer. Galvanometer of resistance 100 ohm gives full scale deflection for 3 milliampere of current. Convert it ammeter range 0 to 10 ampere, voltmeter range 0 to 10 volt. So this is a numerical. galvanometer resistance, it is 100 ohm. First part gives full scale deflection for current 3 milliampere ampere. Converted ammeter range, maximum current is 10 ampere. How will you convert S shunt? We know IG, G, S, G plus S into I, IG, 310 ki minus 3, S, we have to calculate, G is 100 into I, so it is 3, it is 3, 100 plus S, and it is what? 1, 2, 3, 4 zeros S, 3S, S, or it is what? 7999S is what? 300. R.S. 300 by 9997. This is value of, that is 0.3 ohm resistance in parallel with galvanometer. Now second case, G, again it is 100 ohm, voltmeter means R, maximum current can pass through voltmeter is this, and voltage maximum measured is 10 volt. So this is G, this is R, this is your voltmeter. So maximum current will be what? IG. V RI, this is RI. V10 R to be calculated, G 100 RG. So it is what? 3000 R plus 100, 3R, 300, 3R is what? 0072, or R is what? Ohm, in series with galvanometer. Multi-range voltmeter can be constructed by using this galvanometer. ये यूज करके मल्टी वोल्टमीटर बनाना है. Multi-range voltmeter can be constructed by using galvanometer as shown. ये रेजिस्टेंस कनेक्ट करके ये वोल्टेज रीड करनी है, ये कनेक्ट करने के बाद ये करनी है, ये कनेक्ट करने के बाद ये वोल्टेज. Multi-range voltmeter can be constructed by using a galvanometer as shown. We want to construct voltmeter which can measure 2 volt, 20 volt, 200 volt. The resistance of galvanometer is 10 ohm. Our maximum deflection means current through galvanometer is 1 milliampere. Find R1, R2, R3. Resistance given 10 ohm. Current given through this galvanometer 1 milliampere. We want to construct voltmeter to read this voltage, this voltage, this voltage. For this voltage, this is the high resistance connected. For this voltage, this will be high resistance connected. For this voltage, these will be high resistance connected. Again, first, V 2 volt, VRI. What is R here? I is Ig. Ohm's law. This is total resistance, this is current, this is voltage, VRI. So it is 2 G10 plus R1 Ig. 10 minus 3. So it is 2000. 2 plus R1 or R1 1998 ohm. It was not 2, it was 10, and this was second. V to be calculated 20 volt, V will be Z, R1, R2 into Ig. G20, G plus R1, G plus R1 was 200, 2000 plus R2, Ig plus R2, or R2 comes out to be 0.0008 ohm. Third case, V 200 volt, V RI, ये G तो galvanometer था. What was R? R was R1, R2 plus R3 into what? Ig. V, this was what? G, R1, R2. G was 10, R1 200. It is what? Plus R3 into Ig. So this is what 0, 0, 0, 0, 0. 4 zeros, or R3 comes out to be 4 zeros. ये subtract करिए 8, 1 ohm. So these are 2 zeros, 3, 4. This was